In this video, we are going to talk about hypothesis testing. First, we will introduce the definition of significance test. The significance test uses probability to quantify how plausible a parameter value is while controlling for the chance of an incorrect inference. The main goal of many research studies is to check whether the data supports certain statements or predictions. Hypothesis is a statement about a population, usually claiming that a population parameter takes a particular numerical value or falls in a certain range of values. Please pay attention that hypothesis test is about population, not sample. A significance test is a method for using data to summarize the evidence about a hypothesis. Before conducting a significance test, we identify the variable measured and the population parameter of interest. If we have categorical variables, then we are interested in the population proportions. If we have quantitative variables, then we are interested in population mean. The first step of a significance test is about making some assumptions. First, each test makes certain assumptions or has certain conditions under which it applies. A test assumes randomization. In other words, we need a randomized test. Other assumptions could be about sample size or about the shape of the population distribution. We will know more when we look at the next two sections. Step 2. Hypothesis. All tests have two hypotheses about a population parameter. The first one is called non-hypothesis. It is a statement that the parameter takes a particular value. It is denoted as H0. The alternative hypothesis states that the parameter falls in some alternative range of values. It is denoted as the H alpha. The value of the non-hypothesis represents no effect. The value of the alternative hypothesis represents an effect of some type. Hypothesis must be formulated before viewing or analyzing the data. The non-hypothesis is presumed to be true unless data gives strong evidence against it. There are different options for setting up a hypothesis. If we are interested in population proportion, then the non-hypothesis will be the population proportion P. So the P here is population proportion. The non-hypothesis will be P equals to a certain value called P0. Or some value. There are three options for the alternative hypothesis. P doesn't equal P0, or P is larger than P0. Last, P is less than P0. If we are interested in the population mean, then the non-hypothesis will be mu equal to mu0. Again, the mu0 is just some value or certain value by your guessing. There are also three options for alternative hypothesis. The population mean mu doesn't equal to mu0, or mu larger than mu0, or mu smaller than mu0. P0 and mu0 must be numbers. All values given in the hypothesis will be the same. Whatever you set the parameter equals to in the non-hypothesis is also used in the alternative hypothesis. It means if we use the P0 here in the non-hypothesis, we should also use P0 in the alternative hypothesis, no matter the relationship doesn't equal or large or small. Same thing if we are interested in the population means. If we use mu0 in the non-hypothesis, the mu0 will also appears in the alternative hypothesis, no matter which form we use. If the alternative hypothesis is not equal to, then we call the test two-tail test. When the alternative test is less than or greater than, then we call it one-tailed test. So this alternative hypothesis here is two-side test. Those two are one-side test. And similar, this alternative hypothesis is a two-side test, and these two are one-side test. Here is an example from a textbook. You can pause this video and read the question. The mean IQ of all students at a high school is higher than 100. In the math language will be mu larger than 100. This is an alternative hypothesis because the non-hypothesis is always some value some parameter equals a value. Second, the probability of rolling a 6 with a particular die equals to 1 over 6. So it will be the population proportion equals to 1 over 6. It is the non-hypothesis. Here is another example from a textbook. You can pause this video and try to do it by yourself. There are three things to check. First, notation. It must be P or mu from about the population parameter. It cannot be the X bar or P hat. It is about the sample parameter. In non-hypothesis, we can only use the equal sign, and in the alternative hypothesis, we cannot use the equal sign. Last, the number in the hypothesis must be the same. It is either P0 or mu0. The non and the alternative hypothesis are always about the population parameter and never about the sample statistics. So that's why this is wrong. The correct version will be the population parameter P, or the population proportion equals to 0.5. And the non-hypothesis is about the population proportion larger than 0.5. This one is wrong because the range of values in the alternative hypothesis needs to be alternative to the value specific in the non, so it cannot include the non-value. So the corrected form will be P equals to 0.3, and in the alternative hypothesis will be P larger than 0.3. Step 3. Use test statistics. The parameter referred to in the hypothesis has a point estimate. If we are interested in the population proportion, we should use the population parameter P, and we can use the point estimate P hat. If we are interested in the population mean, then we should use the population parameter mu. We can use the point estimate X bar to estimate mu. A test statistic describes how far that point estimate falls from the parameter value given in the null hypothesis. Usually, distance is measured by the number of standard errors between the point estimate and the population parameter. Step 4. P-value. The formal definition of p-value is the probability that test statistic equals to the observed value or a value even more extreme. It is calculated by presuming that the null hypothesis is true. We can use a more general definition. It is the p-value is the tail probability beyond the observed test statistic value if we presume the null hypothesis is true. So smaller p-values provide stronger evidence against the null hypothesis. Step 5. Make conclusions. We report the p-value and interpret what it says about the question that motivated the test. We can reject the null hypothesis in favor of the alternative hypothesis when the p-value is very small. Here is another example from your textbook. You can pause this video and try to do it by yourself. If p-value equals 0.38, we have to know that small is a relative term, and in next section we will get into which values are considered as small. In general, anything greater than 0.1 is considered large, and anything smaller than 0.01 is considered as small. So this particular p-value is not very small. So we said there is no strong evidence against the null hypothesis. If the p-value equals 0.001, then there is strong evidence against the null hypothesis.